last time we talked about value tables based simply on a single operator. And this time we're actually going to assign each part of the WOOF, each letter, a value. And those values are going to be plus or minus. So we're going to have a plus or a minus. And we talked about this a couple times. So we're going to jump into this. And let's go ahead and start with something simple. Let's say we have the WOOF P and Q. Okay? Right now, as it stands, P and Q has no value assigned. But if we go ahead and say, what if we say P is positive and Q is negative? Well, then what do we know about the entire WOOF, P and Q, based on this information that we have about the values that they hold? Well, what we know from our rule is that the AND operator makes the entire WOOF positive if and only if both parts are negative. So P is clearly positive, right? So from P, we get a positive, and from Q, we get a negative. So is this one going to be positive? No, right? No, it's not going to be positive because one part is negative, okay? So that's how we determine the value of this operator. So the overall value, not of this operator, of this WOOF. So the overall value of this WOOF is negative based on the values that each part of the WOOF holds and the operator. So let's look at another example. Let's say we have P or Q. So we'll have P or Q. Okay? And let's say this time the operator itself has been given a value, which it can, and the value that it holds is negative. So what do we know, if anything, about the parts? Well, since the OR operator is negative if and only if both 1 is negative and 2 is negative, we know that since P or Q is negative, both the P must be negative and the Q must be negative, right? In other words, what we're saying is the only way that this operator, the whole thing, could hold a negative value is if it complies with the rule that says that the OR operator makes the entire WOOF negative if and only if both parts are negative. So if this, for instance, were positive, OR, and Q was holding a negative value, right? We're bringing these values down like we did before. Well, we would know that the operator itself would not be negative, right? In this case, the overall value of the WOOF would be positive. Okay? So the only way the OR operator can be negative itself is if the first part and the second part, or both parts, are negative. That's how we get a negative value over here. Okay? So that's how these work. So let's go through another example here. And this is actually where all of those rules that we came up with last time come into play. So let's look at a situation where we don't have as much information. So let's go back to our P and Q. Okay, we're mining our P's and Q's. We're going to go ahead and slap a positive value on the P. Okay, in this case, no other value can be known, either for the entire expression or for Q, because the AND operator makes the entire WOOF positive, right, if and only if both parts are positive. Well, in this case, we know that P is positive, right, but we have no idea what Q is. So positive and an unknown equals an unknown. We have no idea what the value of this operator is. Okay, but if we go and we say, well, let's do our implication operator here. So if P implies Q, and the way you read implication is if P then Q. Okay, if P then Q, let's say the S is assigned the positive value. Or not the S, the Q. Sorry, I was looking at my question marks here. So the Q is positive. Well, what do we know about the implication operator? Well, the implication operator makes the WOOF negative if and only if the first part is negative. So let's come up with our answer here. The only way the implication operator can be negative is if the first part is, if and only if the first part is positive, right, and the second part is negative. That's the only way we get a negative. Okay? So in any other instance, positive, 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 negative, positive, or positive, negative we have here, it will be positive. So in this case, since the Q, or the second part, is not negative, right? Let's look here. It's not negative. Then we know that this whole thing is positive. So we can annotate this like just putting a little positive in here. And it'll be helpful. I'll give you some exercises, but as you start evaluating larger and more complex woofs, it's going to be helpful to go through the routine of marking what you do know. For this first exercise, you're probably actually going to have to draw it out, or at least think about it very carefully. But if you've got a big hairy woof, and you need to know what this, let's just say this were in parentheses, right? And you knew that the Q was positive, it'd be wise to go ahead and mark the operator as positive so that you knew. And sometimes you can even collapse this, and we'll go about that in the future. But then you could just carry down the positive, negative for a whole variety of different things. And when you're all done, you'll come up with the value that the woof itself holds. And this can be pretty cool. We'll actually start solving problems that look like solutions to problems instead of just little quick or cool tricks. So good luck. You can start on those exercises. There's 36 of them, so it may take a little while. But once you get through those, you should feel really comfortable evaluating the AND operator. Right? We got our AND, or we can do AND. We can do our OR operator, right? A little roof, right? Our OR operator, or we can do our little, that's our AND operator, sorry. There we go. And, or, remember our ditch, or our U. Boy, I'm really messing up here. Maybe you'll remember better than I do. Okay, and our implication operator and our inequality operator. So you'll have an opportunity to evaluate all of these, and all you need to do is put a plus or a minus if you can determine the value of the woof to be positive or negative. If you can't, at least mark the parts and the values that you do know. All right, good luck.